to do these processes, and there are now. And because of that, some of these extraction processes are getting somehow obsolete, replacing them with a lesser risky procedures. So just like I said, risk already we have it working in the laboratory, but we need to run, when looking at risk assessment, you need to just look at how to analyze your task. Look at how it is, that is, you design that system, and now number two, you identify this hazard. Is it called for? What is the level of this hazard? Can we replace it with a lesser form of what we pose as hazard? It is important to know that a hazard is any real or potential condition, including typical hazardous condition related to human error, such as time pressure, shift turnovers, and lack of system knowledge. As much as possible, try not to put yourself under unnecessary pressure that could lead at risk for us. If you're working under pressure, you might not be able to be mindful of some of these hazardous chemicals you're using, and because of that, there could be spills. So all this, you need to identify the hazard, then you analyze the risk. If it's worth it. Analyzing risk involves considering the likelihood and severity of the adverse consequence. And we now do the risk assessment to know, just like I said, to make decision whether to continue with that or replacing it with a lesser one. And at the end of the day, you now look at how to control this risk if it becomes more severe. The safety management system element of risk control, also known as risk mitigation, of safety measures to safeguard people, property, or the environment. Always take note that being in the laboratory itself is a risk. So what you just need to do is now to assess before you begin in any laboratory. Do the risk assessment. And now know if you'll be able to interchange a more risky materials or operation with a lesser one. We have different level of containment in laboratory depending on the work, the function we do. Biosafety level. We have biosafety level 1 to 4. And for biosafety level 1, no containment, so to say. We are defined organisms. The organism might not just pose any health risk to any individual, or the risk is just maybe somehow minimal, and with that, you might just require normal disposal of waste. That if you have maybe local or maybe state health management workers that will come and pick. These are agents that present minimal potential hazard to personnel and the environment. The biosafety just little containment, moderate risk, disease of varying severity, like when you're working with samples, HIV samples, influenza samples. In this biosafety level 2, the agents associated with human disease, they pose a moderate hazard to personnel and the environment. In that, you might not even need to autoclave your waste. You just discard normally with hospital waste, and it will be disposed of. And in that, you just need the normal PPEs, or wearing the usual lab coats, your hand glove. Sometimes you might involve the use of face mask. You might not need that. And for biosafety level 3, it has high containment. We have generation of aerosols. The hazard from this could be very serious, it could be fatal, and something when you're handling tuberculosis, yellow fever, even the COVID-19 that we are just coming out of it, we are not fully out of it, will in this will make use of biosafety level 3. All processes must be done using the biosafety cabinet. And the waste from this must be autoclaved before it goes out of the laboratory. Is a must. You have to destroy, you have to autoclave it make sure that you've rendered the waste from the laboratory impotent before you send it to even the general waste outlet. Even sometimes you could still involve even incinerator after that, but make sure that no waste comes out of the laboratory, of a molecular laboratory setting like that, because it is very, very hazardous. Could remember the time during the COVID-19 aspect that we have many healthcare workers coming down with COVID-19. Even some they die. But we thank God for molecular laboratory in Babcock University Teaching Hospital. We didn't record any form of death. We thank God for that. So for biosafety level 4, it has high maximum level of containment, even more than 3. In making use of the biosafety cabinet, you make sure that everything is done there, just like biosafety level 3, but at higher level. And you see some organisms that we looking at Ebola, Lassa, and most of these hemorrhagic fever diseases is being done using biosafety level 4. And the waste too passes through autoclave with bioseal required in laboratory room. That is it. And in this, most times, it even involve you making use of shower, that you don't even go into laboratory with your personal, with your normal, your personal dress. You have to change to what we use there. And even before you leave the laboratory, you must make sure that you pull everything off. There is no way we want to talk about safety without talking about even the design of, I've said in passing before, about the design of the laboratory. For molecular laboratory, to design molecular laboratory is a tedious task because of some of these views. The laboratory should be compatible with mechanical barriers to prevent contamination. Contamination even to the work you're doing and even to yourself. I could remember those days when I was undergoing the training for molecular laboratory, when they were telling us about how we need to protect ourselves, even protect our work, that our trainer then, I could remember, told us about a case where a laboratory, I think their loss then was going to 30 million naira. What happened? They had contamination. Not even to themselves this time around, to even the work. They had to. Almost all their reagent and everything, they had to discard it because they were contaminated. Not until we faced it one of the days when we were doing at the peak of COVID-19 then, that we couldn't work for hours. When our amplification was it was like drawing different map. We can't even understand. So all what we need to do then was to stop. And we start cleaning virtually everything. We discard many things. And thank God that at the end of the day, the contamination ended with our PCR machine. It didn't go to the freezer where our other reagents were then. So it was then I understand how sensitive the work at the molecular laboratory is. So even to your work and even to yourself, that you need to make sure that the barriers are put in place so that there will be high level of containment. The sample preparation area must be different from the extraction room. That is where you prepare the DNA extract. I believe the lecture after this will still tell us about the molecular laboratory, but I need to talk about the safety aspect of it. And also, there will be another room designated. There must be another room designated for reagent preparation. It shouldn't be done in the extraction room to avoid contamination. Also, the amplification room should be a different setting, a different room, a different place within the molecular laboratory. There must be physical separation and preferably at a substantial distance from each other. Each area should be fascinated with adequate requirements. There must be unidirectional flow. Where you start from, you must not go back there. You must flow. It must, until you get to the last place. If not, there could be contamination. For those of us that maybe you've not been to any molecular laboratory settings before, after this program, we just allow you 5 minutes, it's still within this building, to see how molecular laboratory settings should be. We will be expecting us just within 5 minutes. Just come in. Don't be afraid. No COVID-19 sample being analyzed presently in the laboratory. So you go in and see. So there must be unidirectional flow. When you're starting from the sample separation preparation room, you shouldn't go back there. And what you use there mustn't be taken to the next room, not to the third area, not the fourth area. Also, both personal, including cleaning specimen, must be kept in place. You have to remove PPE before leaving one area. The PPE you used at the extraction room shouldn't be taken to the master mist room or the amplification room, so as not to contaminate yourself nor your work. The size of each area should consider space for equipment and bench space needed for preparation. Even within the laboratory, both the molecular laboratory and general laboratory, there should be places designated as clean area and dirty area. Clean area doesn't mean that you can eat there or do any other, no, but at least that place is somehow free as much as possible, or to a level percentage from hazardous substances. In molecular laboratory settings, there must be temperature and humidity requirements, exhaust ventilation, water quality, backup water system, eye watch, ergonomic assessment. Your sittings must be that which requires safety, so that you will not be having issue with your back. When designing a molecular laboratory organizing workflow, ensure that patients and patient samples do not have common pathway. Make sure that you don't take your sample. After collecting the sample, it shouldn't go again where the patients are or other staffs are. It must go in that different from where the patients are. Circulation path should be designed in such a way that contact between the public and biological materials can occur only in the rooms where patient samples are collected. Reception desks where incoming patient registers should be located as close as possible to the entering door. It must not be, the patient shouldn't go for a molecular laboratory setting is risky. Going in for sample collection. Access to rooms where manipulation or analysis of samples takes place, or where hazardous chemicals or other materials are stored, must be restricted to authorized personnel. Usually laboratory technical staff and maintenance staff. There should be restriction. There should be signages on the door or on the equipment about some safety requirements or procedures. The laboratory must be designed to ensure proper ventilation. There must be proper ventilation. Sometimes you could make use of even these air flow out ventilators. Rooms should have a high ceiling to ensure proper ventilation, and all the walls and ceiling should be painted with washable glossy paint or coated with a material suitable for cleaning and disinfection. The paint must be the type that you can clean very well. Even the window blinds should not be that will trap bacteria, viruses, or any microorganisms. It should be the type that is washable. The chairs, laboratory chairs, should not be those net type, those cotton type. It should be like this, that you could clean it. The floor must also be easy to clean and disinfect, and have no edges between the walls and the floor. Make sure that it's not the type that could trap microorganisms within that will pose danger to those that are working. Also, the laboratory workbenches should be constructed of materials that are durable and easy to disinfect, not wood, not steel. Standard laboratory safety precautions. The major route by which laboratory staff acquire work-related infections are either percutaneous inoculation, contact between mucous membranes and contaminated material. It could be as through accidental injection of microorganism. And to reduce the risk of these occurrences, it is imperative that staff have access to PPEs, and you must be trained in how to properly use it, and habitual use of the PPE while working in the laboratory. In the laboratory, general laboratory, and even in the molecular laboratory setting, there are guidelines of how you can either don or doff. The way you wear your PPEs or the way you pull off your PPEs matters a lot. I could remember during the COVID-19 pandemic, what actually led to the laboratory scientists and getting infected was improper way of doffing their PPEs, pulling it off. I could remember we spent hours giving ourselves training on that, because if you don't do it in the normal proper way, though you wear the right PPEs as if you are going to the moon from head to toes, but when you're not pulling it off and if you do not do it very well, you will infect yourself. At the end of the day, you're already incubating inside, thinking you are wearing the right PPEs. The appropriate goggles, the face shields, and all other PPEs should be worn. Effective use of gloves relies on two simple practices. Remove gloves when leaving the working area to prevent contamination, and never reuse gloves. Some will say, no problem, I've cleaned it, I've disinfected, I've done this. No, it could have micro cracks, and it will make them more porous and lose their protective properties. Let's make sure that we wear our glove very well. Please, some of us, we are the habit of handling our phones with glove. And when you just ask them, I've not used it for anything. No. Have that right habit that never undo any of your personal belongings with glove. Either you have used the glove or you have not used it. If you make it an habit, it will be an habit with you that you don't undo any of these things with glove. Next slide, please. I think I've talked about this before, about the laboratory manager. You can give the next one. Limiting or restricting access to the laboratory. The laboratory, we have most of our laboratory in Nigeria, anybody can just go in. Anybody, it shouldn't be. There should be waiting area. There should be the staff lounge. There should be where you can, not just, Mr. Fatai, your sister-in-law is looking for you. Let her come to the laboratory. No, it shouldn't be. There should be restricted access to the laboratory. As much as possible, let's look for how to get just a little place, a little lobby, or a little lounge where we will take care of our visitors. Not just let all Dick and Harry enter. No, they could be contaminated. And at the end of the day, they will even take those contamination out to the community. Washing hands after handling infectious or hazardous materials or animals, or after removing gloves and before leaving the laboratory. Let's make it an habit. I've removed my glove. Though some you are saying, I wore glove throughout, but let's make sure that we practice hand washing. No eating, no drinking or smoking in the laboratory. Please, let's not eat in the laboratory. Let's not contaminate ourselves. Handling contact lenses and applying cosmetics in work areas is not allowed. Mouth pipetting, I'm sure we are not doing that. I could remember those days that we use our mouth to draw WBC. Some of my mothers and daddies, they are nodding. Those days, I knew sometimes I would just suck the blood. And this time around, you can't just practice that then. So let's not mouth pipetting. Biosafety cabinet should be used whenever there is a potential for aerosol or splash. Let's make use of biosafety cabinet. That is even in biosafety level 2. You could see, but in biosafety level 3, 4, you must make use of biosafety cabinet. Use only equipment you are trained to handle. If you went to a laboratory, a new laboratory, and you have not handled this equipment before, why don't you ask how it is being handled, rather than saying, they will be abusing me that I am maybe otondo or new in this, and because of that you now infect yourself, or you are posing risk to yourself. No, train yourself. Make sure you ask how it is being used. As much as possible, avoid working alone in the laboratory, because there could be accidents. So let's as much as possible, let's avoid working alone in the laboratory. We have a lot of precautions, a lot of safety precautions that we need to. Let's not make use of broken glassware. If it's broken, please discard. Let's not manage it, because it is very, very risky. Let's follow proper lab waste disposal procedures. Container that you make use of, 4-liter keg for 24 hours criterion clearance, shouldn't be washed and say, Shebi, I even know the person that even brought the urine. It's someone like me, and you now wash it and take it outside to go and buy. It's soap I want to buy. It's soap. It's not for vegetable oil. It's just for soap and everything. Let's not do that. What I usually even tell them we do in the laboratory, because I don't even want the housekeepers, because they could tell them to discard. They might want to take it, because they might not really know what the risk involved. So I don't just discard directly. What we usually do is to maybe look for a metal rod and put it in a buzzing burner and make sure we puncture the kegs before discarding. With that, they will not be able to use it. But if you just discard like that, sorry, I just pray that the 4-liter keg of palm oil you will buy in the next 3 weeks will not be that same keg. So let's look for how to make sure that it is no more useful, even before taking it out of the laboratory. If the chemicals you are working with splashes into your eyes or skin, don't just gloss over it, please. Let's look for how to quickly clean and rinse with water and inform our supervisor. Whenever there's needle prick injury, we have guidelines, WHO guidelines for that. Please, when you have needle prick injury, don't just start squeezing let it flow through running water. After that, you identify the source. That is, if you can identify, maybe the patient is still with you, you could collect blood sample and do some tests on it. And even you yourself, you test it, then you report within 72 hours to your supervisor. And from there, you could be called to make use of some antiretroviral. Within 72 hours, you start using it, so that it will give you coverage, so that you won't get infected, coming down with maybe hepatitis B, C, or HIV. So let's be careful with that. And also in molecular laboratory, we make use of ultraviolet illumination system. When you are doing DNA gel photography, make sure as much as possible the laser beam should not be, don't look into it with your the naked eyes. It must be looked into making use of our UV reader. Also our hair, it should be chin length. If you know it is longer, try and look for how to tie it, and make sure you wear hair net. Please, your hair, fine, the Brazilian hair and everything, you want to make everybody know, but the microorganisms don't know that. Instead, they could get attached to it. Try, make sure that you tuck everything in, that is not more than your chin length. Also, use proper footwear, not slippers. Open toe shoes, slippers, even if it is 30,000 naira. Better go and buy the covered shoe of 3,000 naira rather than making use of wearing that, it is not advisable because of spillage, because of any hazard that could you are open you could be open to. Then wearing the proper clothing is a must. Do not wear shorts or short skirts in the laboratory. If you know you have that, then before you begin any work, make sure that your PPEs are on. And now we've now discovered that even the lab coat we are wearing now is not lab coats. It is not lab coats. Students, sometimes I will just have to send them out. And even MLS, your lab coat should be more than at least more than 3/4 of your length. Sometimes I give some science lab coat, they say this one is too big, so you won't fit it for lab coats. So let's be careful so that all this we'll be able to reduce. I told us working in laboratory is hazard on its own, so that we'll be able to reduce this hazard to the barest minimum. Next one. Our waste management, we should be involved in this waste management, not leaving it for the housekeepers. You understand this containment even more than them. As much as possible, we should train our housekeepers about what these wastes are, how they should be properly disposed, and we ourselves, we should be involved, because laboratory waste management is a critical issue. Both our radioactive waste, our chemical waste, and biological waste, we should make sure we dispose them properly. And even in laboratory design, our water waste shouldn't be the type that we flow out. It is risky. It should be that it should go into suck away down, septic down. It shouldn't just flow out. That from out to the community, to the gutter, from there maybe to some streams, and it is risky. We should make sure that it is properly managed. Next slide, please. That is the housekeeping safety rules. Next slide. A laboratory safety program is important in order to protect the lives of the employees, patients, and to protect laboratory equipment and facilities, also the entire environment. Neglecting laboratory safety is very costly. Following guidelines keeps employees healthy and protects their well-being. They can perform their job more effectively and be confident that they do not have to worry about being injured or suffering from illnesses. That is, if we make use that we'll be able to contain, have a high level of containment, and we don't expose our staffs, ourselves, to this risk, we'll be able to be more productive, so that time that we need to be at work will not be the time that we'll be on sick off as a result of this hazard that we have introduced to our system. And also it will make us to be more productive. We have a positive atmosphere and we can work more comfortably. Next slide. Neglecting laboratory safety is costly. Very, very costly, to the risk of life. It jeopardizes the lives and health of employees and patients, laboratory reputation, equipment, and facilities. Thanks for listening.
All right, please, we can do better. Thank you, you just moved the presentation. All right, I will be inviting the Vice Chairman of the Association of Medical Laboratory Scientists of Nigeria, Ogun State Branch, Dr. Marco Juala, to do the award presentation to Dr. Ladipo.
Mountains, blue skies, and the sea, rainbow. for this great lecture that we've had and for the good presentation. We are presenting this flag to Dr. Oluwakemi Ladipo.
Thank you for this wonderful presentation. Association of Medical Laboratory Scientists of Nigeria, Babcock Buth branch. Thank you for this. I appreciate it.
Thank you very much, Ma. God bless you. All right, just a quick announcement before we invite the Amlsn choir to do their presentation. Please, the CPD activity form, I don't know if we have all filled that form. I want to advise us that without filling that form, you won't be given certificate of participation. So please, if you haven't done that, ensure you go to the registration desk and fill that form. And you fill it in such a way that that is how your name will appear on the certificate. I will be inviting the Amlsn special choir to do their special presentation. The Amlsn choir, all right.
Sound check.
Good afternoon, everybody. Okay, my name is Susan Adetiba, and I'm the departmental chaplain, and I present to you the Amlsn Babcock chapter choir. So we're here to present a song, and I just ask that you sit tight and enjoy. Thank you.
Yeah. Lady, hang on. Here comes a time when we hear a certain call, when the world must come together as one. And there are people dying, and it's time to lend a hand to life, the greatest gift of all.
Love is all we need. We are the world.
their cries for help will not be in vain. We can't let them suffer. No, we cannot turn away. Right now, they need a helping hand. We are the world. We are the children. We are the ones to make a brighter day. So let's start giving. And there's a choice we're making. We're saving our own lives. It's true, we'll make a better day. Just you and me. When you're down and out and seems no way at all, but if you just believe, there's nowhere we can fall. Let us realize, oh, that a change can only come when we stand together as one. We are the world. We are the children. We are the ones who make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we'll make a better day. Just you and me. We are the world. We are the children. We are the ones who make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we'll make a brighter day. Just you and me. We are the world. We are the children. We are the ones who make a brighter day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we'll make a better day. Just you and me. We are the world. We are the children. We are the ones who make a better day. So let's start giving. There's a choice we're making. We're saving our own lives. It's true, we'll make a better day. Just you and me. It's true, we'll make a better day. Just you and me. It's true, we'll make a better day. Just you and me. It's true, we'll make a better day. Just you and me.
All right, please, we can do better than that, please. Let's just appreciate the student. You know what? I was actually thinking, if possibly you put a ribbon blocking my eye, I would have been thinking that this is actually Michael Jackson, Lionel Richie, and the All-Star Choir doing this song. They did it so beautifully well. I must commend the Mercer Choir for doing justice to that song. All right.
Okay, Nimelsa Choir, on behalf of the Association of Medical Laboratory Scientists of Nigeria, Babcock University Teaching Hospital, please make sure you see me for a special gift for this wonderful presentation. You have a special gift from us. Thank you very much.
That is coming from the chairman himself. Please ensure you wait and collect the gift immediately after the program. All right. We are gradually coming to an end, but we still have one more presentation to go. And The title of this presentation is actually on hands-on practicum in molecular techniques. And I will be inviting MLS Olaliko Kemiki, who will be represented by MLS Adeniyi John, to please step forward. All right, please, let's appreciate him as he comes forward, please. All right, I will be inviting Mrs. Blessed Ibiam to read the citation.
Good afternoon, everyone. I will be reading the citation of Mr. Olalekon Ademola Kemiki. Mr. Olalekon Ademola Kemiki was born in the early 90s in Kano State. He hails from Imaka, Odogbolu, Ogun State. He had his primary and secondary education at the Bola Immaculate Group of Schools, Oruta Challenge, Ibadan, Oyo State. He then proceeded to Ladoke Akintola University of Technology for his undergraduate studies and graduated with a Bachelor in Medical Laboratory Science degree in 2015. In the quest for personal development in the area of molecular biology and bioinformatics, he dived into various professional certifications organized within and outside the country, both online and on-site. As a young researcher, his present era of concentration is employed. As a young researcher, his present area of concentration is exploring therapeutic edge of the obesity paradox, fragment-based drug design, and antimicrobial resistance. He has several co-authored publications, both in local and international journals, to his credit, and others in peer review. Olalekon Ademola Kemiki is a staunch believer in SDG 3, and this played a key role in his recently won Micro Grants Award by Just One Giants Laboratory, France, where he is currently studying and reporting carbapenemase resistance in Africa. He was employed as a medical laboratory scientist, molecular, by Babcock Molecular and Tissue Culture Laboratory in the year 2020, and have played a key role in testing over 15,000 COVID-19 samples, training of scientists and non-scientists on molecular and bioinformatics techniques with hands-on practicum, guiding of students in various molecular research, among others, and expansion of molecular diagnosis at the facility. He is a dedicated, focused, and determined individual who is gradually preaching the message of re-strategization of medical laboratory science in the era of personalized medicine. He is a willing learner, open to collaboration, and always willing to add and challenge existing knowledge. He is a strong believer in volunteering and has done so within and beyond the shores of Nigeria. He is always open to volunteer and impart anywhere he finds himself. He is a member of Association of Medical Laboratory Science Council of Nigeria, Just One Guy's Laboratory, and Amlsn, and Health and Safety Nigeria. Please, let's make welcome Mr. Olalekon Ademola Kemiki.
Good afternoon, sirs and ma'ams. Good afternoon to the elders in the profession. Good afternoon to the students here seated. And good afternoon to my colleagues. Yeah, my name is Adeni Oluwasegun John, and I'll be standing in for my friend and brother, Oladekan Kemiki. He is unavoidably absent, but I bring his best wishes to you all, and he is following us right on the YouTube. So I've been honored to present a paper on hands-on practicum on molecular techniques. And I want to say that this is more or less the climax of all that we have been here for the past 2 days. It's a climax in the sense that it's going to give us a raw, a virtual look at what we do in molecular laboratory. It's going to open our eyes to those things we do in the wet laboratory or in the wet portion of the molecular laboratory. I know that over the lectures we've had, we've been able to delve into what dry laboratories is all about, or are all about, and then we've been able to see how they both exchange ends, both the dry and the wet laboratory. So what I want to do this afternoon is to lay more emphasis on the wet laboratory. I remember Dr. Ladipo Kolawole mentioning the fact that there are a whole lot of effort that you can put in place, especially when you are doing dry laboratory work. But you only find out the reality when you get to the field. And where the field remotely lies is in the wet laboratory, because that's where you put to use all that you might have designed using the dry laboratory. Yes, it has been established that using the dry laboratory, all you need to do maybe is just to have your laptop, smartphone, then connect to the internet. Then you can do things online and all that. But when it comes to the wet laboratory, I will not be able to dress like this. You understand what I'm trying to say? I will need to have my dress done and kit appropriately before I enter into the wet laboratory. So that's the background to what we want to look at this afternoon. And I'll be guided by this outline. All right, so let's see an overview. Why molecular diagnostics are important? Why are they important? Because it's good for us to know why they are important. I mean, you need to know why we are doing what we are doing in molecular laboratories. So I will just itemize few of them. I believe you can all see. Today, cancer is everywhere. When I was growing up, breast cancer used to be a very strange thing in our community. But today, as I'm standing before you, I can count on my fingers people I know personally that have been killed by breast cancer this year alone. And if I can know up to 3 or 5 people, how much more the entire society? So, molecular diagnosis will help us, one, in the area of risk assessment, screening, differential diagnosis, staging, prognosis, therapy selection, therapy monitoring, surveillance. These are areas in which molecular skills or techniques could be devised, to maximize it in the area of diagnosis, especially cancer diagnosis. Okay, so, and then we talk about diagnosis of infectious diseases. Notable of these infectious diseases is COVID-19. And I want to believe that all of us, we agree with me that COVID-19 has revolutionized the world. And we may say in a negative way, but in a way too, it has also changed our ways and manners of thinking positively. Because today, we know that there are certain things we cannot take for granted. And COVID-19 is still very much around. Just like, if you watch the Chinese media very well, you see what I'm saying. It's still very much with them. So then we talk about lung cancer. I've stressed that. Then we talk about HIV and AIDS diagnosis. These are areas in which there are molecular diagnostics, are very, very important and salient. And we cannot but look at it in details. Sample preparations. It is important for you to note that having come up with your ideas, there's a need for you to understand the nature of the sample you're going to be working with. There's a need for you to understand the nature of specimen or template you will be working with. Now, what am I saying? If you are working with a bacteria, this will guide you on the level of the safety level you're going to employ. It will guide you on the nature of the kit you procure. It will guide you on what you should be prepared with at all time. For instance, if you are working with virus, you need to know what safety level do you need to employ. Is it safety level 2, safety level 3, safety level 4? So while you are trying to work in a molecular laboratory, you must understand the nature of the sample you are about to work on. Are we all on the same page? All right, thank you. So sample selection is very, very apt. You must understand the origin or the source of your sample. Is it going to be blood? Is it going to be hair? Is it going to be, stains? Is it going to be smears and all that? You must understand and select properly. Then samples collection. Then you collect your sample as appropriate. Then samples packaging and transportation. That's another key area. Why do you need to package your sample and transport appropriately? Because you don't want to serve as an endangered species to the society. Are we all following? So, and then sample storage. While your sample is now in the laboratory and you cannot work on it immediately, how do you undo it? Such that you do not, destroy what you are about to work on and then waste your resources and funds. So you must understand what the nature of sample is and what the storage demand of that very particular sample. Then finally, it has been said that inactivation is the first phase of extraction. Some laboratory erroneously target deactivation. I beg to disagree, because if you deactivate, what else are you looking for? So in a way to curtail and to make the samples friendly, you inactivate. You reduce the severity or the infectiousness of that very particular sample. More or less like you are curtailing it and making it user friendly. Okay, so extraction types. Basically, we have two basic types of extraction. And we talk about the liquid or chemical phase nucleic acid extraction. In this very particular method, all you use, they are chemicals. They are chemicals. Well known of these chemicals is chloroform, phenol. These are chemicals you use. But it is discovered over the years that these chemicals are harmful to our body. Hence, it is better, and today in the world, there is an innovation. There are innovative ways in which we try as much as possible to ensure that what we use are not hazardous to us and to the society at large. So, this group of techniques highly relies on different chemicals. Thus, extensive chemical preparation is required. While we have the solid liquid phase nucleic acid extraction, it's like a step higher than the liquid phase. It employs the likes of solid phase, what we call the column, the spin column, and in the spin column you can have the likes of the resin, you can have the likes of silica gel, and also you talk about the magnetic beads. These are modern technology that will not expose you unnecessarily to the hazardous chemicals in which liquid or chemical phase nucleic acid extractions exposes you to. Then extraction techniques. one thing is sacrosanct. The essence of you extracting from, take for instance, a whole blood, is because you want to get the template. Usually, the template we use in molecular laboratory, they are nucleic acid. And so nucleic acid, as we know, they are either DNA or RNA. And then coupled with it, we have the protein. So when you get a whole blood, for instance, the area of interest is not the whole blood. You need something in that whole blood, be it the DNA or RNA. And so when that is the case, you need to destroy the cell membrane. You need the nuclear envelope to be lysed. You need to remove the contaminant, and as well as stabilize your nucleic acid of interest. Precipitate it, maybe using the likes of EDTA, and then you do the nucleic acid washing and elution. Elution can be done using simple nucleus-free water. So I'm going to pause now, show you, since we're talking about hands-on practical, our practicum, it's not going to be all lectures. So you're going to sit back and see what we do when we talk about extraction. So the ICT team, no, the slide before this. Okay, so you can play. Okay, so we're going to look at this. This is just a kit. I must say that there are lots of kits in the market for RNA or DNA or nucleic acid extraction. So please don't master the name of this kit in any way. Just understand the basic principle. There are certain things that are constant, and there are certain things that are not constant. Yeah, I've said part of those things, or some of those things that are constant. But in this case, when it comes to kit selection will be based on the nature of work you are about to do. I hope we are on the same page. So this is just a simulation of what extraction is all about. Okay, so you vortex, and some of the extraction kits will require you to heat, to expose your sample to heating. Oh, thank you very much. I think we can pick the sound. This is an extraction from the whole blood. All right, so thank you. I must say that when you are extracting, there are different techniques you can devise. You can use the manual extraction method, more like the one we have just viewed. You can use the semi-automated method, and then you can use the fully automated method. We are privileged to be in an environment or in a setting where these techniques are available. You can afford yourself the opportunity of coming to our molecular lab right up there to see what we've just explained here. And you will be glad you did. So let's move on. The next slide talks about nucleic acid quantification. After you are done with this extraction, there's another phase to know whether what you have extracted is truly what you had in your mind. So there are methods to do that, to quantify the nucleic acid you have extracted. For instance, you have extracted a fluid, colorless fluid. You are not sure whether what you have extracted is DNA or RNA, or whether the quantity of the DNA in that fluid is something you desire or not. So there is a machine that does that for you, and there are various methods of doing that. We have the UV spectrometry method, we have the nanodrop spectrometry method, and the fluorometry method. So these are methods you can use to quantify and to know what is the level or the concentration of the fluid you have just extracted, what is the concentration of DNA or RNA in it, then how pure, what's the purity level of that very particular fluid you have just extracted. There is a small tool that can give you those answers. It is expected that your purity level should be between 1.8 to 2.0. So there is a machine, a tool that can do that. So we'll just watch that briefly too and see. Okay, so can we have it? Okay, so this method is based on nanodrop. So we'll see how you can quantify. Really, after you might have extracted, you can then quantify to know whether what you have extracted is your desired, target or RNA or DNA of interest. And that's an interface on the machine where you can select what you think you have on your mind. So this is an example of a nanodrop spec. You ensure you wipe it and ensure what you are using does not contain any DNAs or RNAs. Then just like our conventional spec, there is a need for you to blank too. So you blank it before you start to measure. Then after you have blanked it, then you now measure your samples to see the concentration and as well as the purity level. So from what you can see displayed over there, we can see the concentration of the DNA in that very particular sample too. It says that it has 228.4 nanogram per microliter of what? Of DNA or RNA. Then the the wavelength is what you see as A260 or A280. The A260 goes for the DNA and RNA, while that's absorbance of that you use in measuring it. For the A280 is for proteins. And then you look at the purity too. It gives you the purity level. And so that's what we do when it comes to quantification. Because of our time, I would like to move on. So immediately you are done with extraction and you are done with your quantification, there is a next step. And that's what we call master mix preparation. Also, when you talk about master mix, it's just a word that has been coined out, I think, in molecular settings. It's the same with reagent reconstitution we use in our conventional laboratory. So a kit comes from the manufacturers, and in the kit you have the manual. I want to say that if you want to be a good molecular scientist, you must be somebody who is ready to read and ability to equally, digest things and interpret appropriately. There was one particular time during COVID-19, Chinese made a lot of billions of dollars from COVID-19 actually. They were the major suppliers of our kits. And lo and behold, there was one particular kit that was supplied. Everything about that kit was written in Chinese. And so we were confronted with this issue that we must interpret in order for us to use it. And so we needed to download Google Lens for us to read Chinese. And that's how bad it is. But thank God when Danjin representative, Danjin is a company from China, when they came to our laboratory, they were the one who explained to us that that kit was not actually meant for Nigeria. It was just guys from Nigeria who went to the street of Chinese cities and, they just bought what they have and then sent it to Nigeria. So what am I saying in a nutshell is, nothing is constant as to kits, and you must be ready to master each kit manual that you are supplied with. As long as it can extract your, target template. So also in master mix, your kit will be supplied. Take for instance, you want to run COVID-19 test, and you are supplied with, maybe let's say, Danjin kit, for instance. You need to read the manual of Danjin kit and then understand it properly in order for you to know what volume of constituent or component are you taking and what volume of A are you taking. Now, but basically, generally, these are the main constituents of master mix. Master mix must contain the DNTPs. Are we all following? It must contain the DNTPs. It must contain the PCR enhancers. This can be magnesium chloride. It can also be potassium. Are we all following? Then we have the tag or DNA polymerase. I think, as of today, it's still the most important enzyme in the entire molecular laboratory. Why? This enzyme has been said to be heat stable. You wonder that protein should be digested when it comes to heat or exposed to heat. But in PCR, you go as high as 95 degrees Celsius, and yet this enzyme will still remain intact. And that's why it is a blessing to us having tag polymerase around. So we have buffer solution. We have your primers and probe or dye, depending on the type of experimental design you are going for. So it's very, very important for you to note and check for these items anytime your master or your kit is being procured. Check whether it has the DNTPs, check whether it has the polymerase, the enzyme, check whether it has the buffer which can contain the enhancer or the cofactors, and ensure that the right primers or probe or dye, in any case, is supplied. Okay, so we will look at it briefly. This is from our own lab. And so we'll look at it briefly, what it entails for us to do master mix preparation. So, because of our time, I won't want to belabor us with all that we have here, but maybe we can do it quickly and see how we can run through it. Okay. Okay, so why is it inverted? Okay, maybe because of our time and the, I don't know, the way the video is structured, it appears to be inverted, kind of. But what I'm doing basically there is, before you start your master mix preparation, there is a need for you to ensure that the environment you are about to work in is safe. And so you must ensure that before you start your work, you disinfect the entire chambers or the area where you're going to work. And basically we use two basic solvents in doing that. We either use 5% bleach, you call it hypochloric acid, or you use 70% alcohol. So when you do that, after you might have done that, then you now look at the materials and the equipment you're going to use. Now in this case, basically we use the biosafety cabinet. If what you are working on is highly virtuous, then you use the vortex and you use the microcentrifuge. This microcentrifuge is unlike our normal centrifuge. It can spin using 1.5 microcentrifuge tube or even 0.2 PCR tube. So that's what you have there in the biosafety cabinet. Then when you are done, you ensure that you bring out your kit, you allow it to thaw, and when it has thawed, you then prepare the number of reactions you are about to go for. Take for instance, you have 5 samples. When you are preparing the kit, you are preparing your master mix, you had, aside the positive and negative control, you had maybe 1 or 2 additional, volume in order for you to, create for wastage and all that, or pipetting and all that. So for instance, you have 5 samples plus 2 positive, that's positive and negative control, then you can add additional 2 or 3, making the total volume of your reaction per constituent maybe 10 microliter. You understand what I'm trying to say? So you pick 2 microliter of your buffer, of your tap polymerase, of your primers or probe solutions and all that, then you pick it into a tube, you label. Then after you might have done that, then you now pick from the kits, majorly in COVID-19, especially when you talk about Danjin kit, it comes in solution A and B. Solution A basically will contain the tap polymerase, the enzyme, while the solution B will contain the magnesium chloride, the DNTPs, the buffer and all that. So let's say per reaction, you are asked to pick 5 microliter of solution A, 5 microliter of solution B. So you take 5 each into your master mix labeled 1.5 microcentrifuge tube. Then you now multiply it by the number of your reactions, say 10, say times 10. So that will constitute what you do as for your master mix. Okay, so this is another video. You can move on to the next slide. No, the one before now. Okay, so you can play a part of it. Let's see whether we can get it right this time. Okay, still invertly. All right. So when you might have done that, then you now aliquot from your master mix, the master mix you prepared in the 1.5 microcentrifuge tube. You can now aliquot it into your PCR tubes. Sometimes the PCR tubes can be in form of a plate. It can be in form of a tube. It could be attached or joined together, or it could be singly presented. So you just apply it according to the manufacturer's directive. So when you are done, you then add your template. Your template is either DNA or RNA this time around. So when you are done, when you have added the template, the next thing you do is to take it to the PCR, to the application room, where you will arrange what you have done or prepared in the PCR machine. So that leads me to what we call PCR. PCR today is very, very popular in the parlance of laboratory medicine, but is a word coined from, 3 key words. The P there stands for polymerase. I've said it. This enzyme is the most important enzyme in the laboratory landscape, molecular laboratory landscape. Then we talk about the chain, which is cyclic reaction. And then we talk about the reaction, which is the biological activity mediated by the enzymes. So the type polymerase governed cyclic reaction is known as what? As PCR. So we have types of PCR. You know, just like we grow each day, there have been development to when it comes to PCR. There are PCRs, you know, we consider the pros and cons, then a new one will be invented, and then you consider the pros and cons again, a new one will be developed. You know, that's how we get to where we are today. So before now, or let me just read down, we talk about conventional PCR, we talk about allelic specific or mutation specific PCR, we talk about real-time PCR, we talk about reverse transcriptase PCR, alt-start PCR, and nested PCR. These are just some of PCR types. So conventional PCR, in our conventional PCR, just like I've mentioned earlier, these are the basic process you pass through. Okay, so you have your thymocycler, you have your type polymerase, the DNA sample, the primers, the mixed buffer, the nucleotides, and the PCR tube. And then you look at the processes. You talk about the denaturation phase, talk about the RNA phase, talk about the extension phase. And what we have there constitutes what I talked about earlier as our master mix. You take it to the PCR machine, the thymocycler or thymocycler in the sense in conventional laboratory. Then afterwards, you set up this process on it, and then you wait. So immediately that is done, you bring out what we call your PCR product. This is how you set up an example of how we set up our conventional PCR. You look at the denaturation temperature, the number of minutes it's going to take. You look at the RNA and then you look at the extension. Then you continue that way. Okay, so this is what you expect to happen in the PCR. You are expecting that your target fragment, with the aid of the primers and probe, should, you know, be replicated. At the phase of denaturation, a double-stranded DNA will unwind. Are we all there? And then your prepared or your procured primers or probe will help to locate the fragment of choice, bind to it, and then there will be a new DNA double-stranded formed. And that will continue cycle 1, cycle 2, cycle 3, cycle 4. By the time you get to like the 30th cycle, you'll be having something of billion copies of that very particular fragment of interest. So this is an example of what we talk about. After first cycle, you have 2 copies. After the second cycle, you have 4. And then it continues like that. So after you are done with the PCR, there's a need for you, I mean conventional now, the PCR product you have, you then do gel electrophoresis on it to be able to, you know, analyze your results. So electrophoresis is a method of separation and purification of micromolecules such as DNA, RNA, proteins based on their nest charge and what? And size. So the PCR products are aggregation of numerous but identical DNA fragments of the same base pair length of the target gene. The detection and analysis of the product is carried out by what? Agarose gel electrophoresis. So you do the gel electrophoresis. I want to liken this to our common genotype. I mean, for those of us in hematology, you compare, you have your control bands, right? Then you compare your samples, the test, with what you have as your control band. In gel electrophoresis, almost the same principle. So what you have is, you have the DNA ladders. You know their base pair. You know their unique, you know, bands and all that, formation. Then what you have as your sample or your target DNA or RNA, I mean DNA this time around because it might have been made to be complementary DNA. Then you now compare it after the gel electrophoresis has been done. So when you are doing the gel electrophoresis, there are certain things you must know. One is, for you to be able to visualize your result afterward, there's a need for you to include dye. while you are making the agarose gel this time around. More like your cellulose acetate paper over there. So when you are preparing your agarose gel, there is a need for you to include something that will help you to visualize the result at the end of the day. So over the years, we use cybergreen, we use ethidium bromine, and today, EZ Vision blue light is reigning. Why? Because it has been said not to be carcinogenic in nature. So thus, the products are instantly visible by ultraviolet trans illuminator. That's what you use afterward. When you get your result, you place it in the trans illuminator using your UV light. Then you are able to see the picture and see the bands. Then compare it with your DNA ladders and see whether the base pair or the bands are uniform, are alike to what you have targeted. Okay, so this is an example of the gel tank that we use. And this is an example of gel results that we can have. Okay, so another very important PCR is real-time PCR. Real-time PCR. Today, we talk about COVID-19. And with the aid of real-time PCR or the transcriptase, PCR, we can, in a real-life settings, monitor all that is happening in the PCR machine. What real-time offers you is, just like in the pidgin parlance, they will say, as it happen, you dey see am. Like as the thing is happening, live and direct, you can view it as it's happening. You know, the PCR machine, they are usually in a forms that are not too admirable, kind of. You just see it like a box somewhere. You know, when it was in conventional era, you cannot really know where you are. But with the real-time PCR, you can actually monitor where you are per stage, per the process. Because the real-time PCR will be connected to its own computer. Are we all there? So whether it's in the denaturation phase, you can monitor it on your PC. Are we all there? And then when the extension has even started, you can monitor it. During COVID-19, before a run is completed, we can tell whether somebody will be positive or negative. We can tell. Why? Because we can monitor it on the screen and see that this person has already picked up. There's a threshold already. Are we all there? There is a quantification already. We can deduce it. We can predict. We can say, okay, this person will be positive. This person will be negative. Even before this entire cycle is completed. So as we know, real time allows us to measure minute amount of DNA sequence in a sample. Okay, so the ICT team, can you help us play this so that we can see how the real-time PCR works, really? Okay, so this is an example. We are cruising home anyway. This is more like preparing its own master mix again. Yeah, you can continue. Yeah. Okay, so we can see, I said it earlier that when you have prepared your master mix, there's a need for you to alicot it to your PCR tube. In this case, the PCR they're going to use as a microtiter plate kind of, tube or settings. You can see it there. It's a 96 wear microtiter plate kind of tube. So this is a type of PCR tube. But don't be shocked if you see another PCR that does not use this same type of tube, because it's not constant. Each PCR machine has its own specific tube. Then after that, you can see during the video that the person tried to alicot the master mix into the PCR tube, and as well as follow it up, adding the template, then seal it up. This is the type of, we have something like this too in our laboratory, where you seal it up with a micro seal film, then you ensure that it's properly sealed before you take it into the PCR machine. So we'll see, this is an example of a PCR machine. We can see it now, well fitted. This is an example of a real-time PCR. And this is an applied biosystem PCR machine actually. So when you open the interface, you are expected to set up the process, the detection, the detectors. You are expected to assign and all that. Then this is the result. This is the way you analyze the result. Especially when you are talking about relative experimental design. With that threshold, you can determine the CT. Then we can see the CT there. I will advise you, if you want to see this thing real life, just see us immediately after this. Just look at it in a laboratory. Okay, so that's one. Then we have another one. This is more specific when it comes to, now when we talk about real-time PCR, you talk about relative design, you talk about absolute design, you talk about the SMP or genotyping, then you talk about HRM. These are some of the designs that real-time PCR offers. So when you're talking about relative, that's what we use majorly when we are talking about gene expression. Are we all there? You can play the second video. Let it continue while maybe narrate or talk in between. So real-time PCR offers us quantification of gene expression. I've said it. When you are doing the relative design, you are really out for gene expression. When you want to know the copy numbers analysis, you are talking about absolute. And that's what you use. That's what we use in our lab for hepatitis B viral load, hepatitis C viral load, or anything that has to do with quantification, knowing the exact number of copies. Then, okay, you can continue. Okay, so when you are talking about real-time PCR too, there are certain things that are very, very important. You talk about the dye-based work, or you talk about probe-based work. They both have their advantages and disadvantages. When you are using dye-based work, you will run your test or your experiment batch after batch. What am I saying? When you are doing real-time PCR or relative quantification this time around, there's a need for you to compare what you have gotten with what we talk about, what we call housekeeping genes. It's more like you are saying you are using test versus control. You use your control to adjudge what your test gives, right? That's the same thing. So when you are talking about real-time PCR, there's a need for you to normalize, especially when you are doing relative design. So when you are doing that, there is a need for you to compare it with what we call the internal control or the housekeeping genes. So when you do that, in the dye-based work, you will run the gene of interest first, then thereafter you run the IC or the housekeeping genes next. That's like you going through the process twice, right? But in probe-based, probers are giving you the opportunity to do the two together. Are we all there? You can set up different channels for your target or your DNA of interest or anything you are doing for your test, and as well as set up the IC. So it's less cumbersome. Obviously, it's more expensive. Probe is more expensive. Dial is less expensive. Probe is less cumbersome. Dial is more cumbersome. Are we all there? One is prone to contamination. The other is less prone to contamination. So we have the pros and cons of each of them. So when you go to a molecular laboratory and they ask you, what type of experimental design do you want from us? And you want to do research. And they say it is probe-based. You know, you're going to design your probe and primers the same way you design other things. So please, if the cost is or the bill is high, understand the reason. It is because you have multi-channels that you can get. But when you are using dye, you can do it often, go back for a sheep or a sheeper. Okay, so this is a typical example of relative work. And then we talk about the threshold, we talk about the dark curve, and where we have the green light is majorly the area of interception where the fluorochrome dyes have been excited. And so we read it in cycle. So where it meets the threshold, the cycle of threshold, where it meets with the emitted or the release or excited substance, be it the DNA that has been coated in the master base, then you have the bar. And that bar, we show the equivalent of the quantification. That's what we have as CQ or CT. You must have heard people say somebody has a CT of 16, especially during COVID-19. The lower the CT, the higher the concentration of the disease. Are we all following? All right, so these are some of the conditions that you must take note when you are running real-time PCR. You must look out for the optimum reaction condition. Primer designing must be very, very serious when it comes to primer design. You must optimize it and ensure that it works effectively. So we have the application efficiency, you have the quality of your RNA and DNA, you have the pipetting efficiency. So that's what you do basically when it comes to real-time PCR. So because of our time, I will implore you to please, you can visit us anytime in our laboratory to see firsthand all that we have given you, in a nutshell. Okay, so can we go to the next slide, please? Okay, so knowledge increases by sharing, but not by saving. Thanks for listening, and God bless you.
Please, we can do better than that. Please, let's appreciate MLS John Adeni. All right. I must say that this lecture is more of practical than theoretical. Just like he said, we have our molecular lab just with this same building. Possibly immediately after this, for those who are interested, want to see all these things that he's just talking about, you can as well visit our molecular lab. Just it's the same building, the second floor. I will be inviting our chapter chairman to do this presentation to our speaker. And at the same time, he will also be doing the closing remark immediately after the award presentation. So MLS Olusonya Timitopo, let's make him welcome.
So I'd like to invite MLS John Adeni. Please, can we give him a round of applause? I have discussed with Mr. Adeni before that, well, when he gets tired of the molecular lab, which I expect should be very shortly, his office will be waiting for him in the Department of Medical Lab Science as a lecturer. I'm sure we will accept him as a lecturer. Is that not it? Yes. So we are still waiting for you in our department. When you are a bit tired of the molecular lab, we are waiting for you because you are a lecturer material, sir. I've told you, sir. And this your presentation has also shown that. So on behalf of the Association of Medical Laboratory Scientists of Nigeria, Babcock University, and Babcock University Teaching Hospital, we'd like to appreciate you for this wonderful presentation. And we would like to also say that you should please keep it up. Thank you very much. Okay. So we have finally reached the finish line. So for those of you that have reached the finish line, please can you give yourselves a round of applause? You are the people that really give the icing on the cake of this conference. I would really like to appreciate you. It's been an eventful program and it's been a wonderful one. I've also gotten a lot, although I was jumping up and down, but I've gotten a lot. I've been enriched by this program, and I'm sure you have. Please, if you have been enriched, can you please once again clap for the organizers of this program? I would like to quickly use this moment to appreciate one or two persons. Well, in absentia, I really just have to acknowledge him, the head of department, Babcock University, that's Medical Laboratory Science Department, Babcock University. He's really been a father to us. Almost all the offices that I had to enter, he entered those offices with me so that this program will go well. He practically entered those offices with me. So I really want to appreciate him. Can we please clap for him? He was at the forefront. He was at the forefront for us to make sure this program went well. I also want to appreciate very specially the LOC, the local organizing committee, starting from the chairman, MLS Adeyemi. Please, can we give him a round of applause? He did a very tremendous job. The secretary, I told her once that as a chairman of this association, there are some people that I call my inner caucus. People that make sure that when I look back, I must see them. That will make me happy, and that will make me know that, yes, I'm still on track. MLS Victoria Joseph, can we give her a round of applause? Thank you very much, ma, for all you have done. I also want to especially appreciate the man we call the engine room of our association. Since we came into into leadership, he's not a member of the ESCO, but every project that we have had to do, his signature was there, his hand was there. And even in this program, there are so many things going on now in this program that I am not aware of. And many of us, we have not seen him, but he has been doing a lot because the program is on his head. MLS Olusegun Agbola, I don't know where he is. He's at the gallery there. Thank you so much, sir. God bless. Please, let's clap for this very diligent, hardworking young man. Thank you so much, sir. God bless you. And then, of course, a member of the planning committee also, not so strong at the moment, was supposed to have presented today. MLS Kemiki Olalekon is a very dynamic young man. Please, can we appreciate him for all his efforts? I want to especially appreciate members of the executive committee. By the grace of God, many of us are young in that committee, but we are doing great things. That's just it. Beside me here is our secretary. We are doing great things, and God has been helping us. So I want to appreciate every one of them for the hard work that they are putting into making sure that this chapter move forward. So please, can we appreciate them, please? Don't get tired of clapping. I will give you Rob to rub your hand when you are done. I also want to appreciate very specially our elders in the profession for all the things that they have done, all their contributions, all their support, words of encouragement. I want to appreciate every medical laboratory scientist in Babcock University and Babcock University Teaching Hospital. Please celebrate yourself. You guys are doing very great things. We are unique, and the results are showing. I want to appreciate very specially, let me start from the top, then I will go down like that. The president of NIMELSA, Babcock University. President of NIMELSA, Babcock, I don't know where she is. She's an exceptional lady. She's one of the best we have had so far. She supported us. This program is our chapter program, but it seems as if it's a combination of students and scientists organizing this program. I want to appreciate her. I want to appreciate the ESCO of NIMELSA, and I want to appreciate very specially the protocol committee. I want to appreciate the choir for their efforts. I want to appreciate those at the registration stand. They are all our students. I want to appreciate very specially I want to appreciate the final year students. Yes. I want to appreciate the 400 level students. They were in a Zoom lecture this morning. But As they were using one hand to receive lecture, they were using another hand to work. So I appreciate you, 400 level students. God bless you. Thank you very much. I want to appreciate the 300 level students. We all did it together. Every student of medical lab science, God bless you. Thank you so much for your efforts. Then lastly, I want to appreciate God Almighty for all that He has done for us. We took a step of faith. This CPD could have been suspended till next year, but we just took a step of faith, and it paid off because God was our support, and we appreciate Him for all He has done. Thank you very much once again. When we call on you some other time, please make yourself available. God bless you. You're welcome.
All right, to wrap this program up officially, I'll be inviting Pastor Enoch Okorochi for the closing prayer.
In Jesus' name we pray. Shall we rise? We are saying thank you, Jesus. Thank you, my Lord. We are saying thank you, Jesus. Thank you, my Lord. In the name of Jesus, for you are indeed Alpha and Omega. You started with your people and you are ending with us. Lord God, we commit all that we have learned into your able hands. We pray that let everything we have learned this day be internalized and become part and parcel of us. We came in black and white. We are going in multiple shining colors. Father, let the feedback of this teaching be glorious in our practice. Thank you. Bless your people, even the executives and those that have really given us. He said that the liberal heart shall be made fat, and he that watereth shall be watered also. Water them your own way. As we go, we are not going out of your presence. Let your ever-abiding presence be and abide with us, now forevermore. Amen. May we share the grace of our Lord Jesus Christ, the love of God, and the sweet fellowship of the Holy Spirit be and abide with us now forevermore.
Thank you, sir. Thank you, and God bless you all.